Okay, here, in this section, we will have 5 or 6 examples to show how to use the two equations to calculate the stress, the shear stress in torsional elements. Okay, the first example is very easy. You just need to directly use the equation to calculate the shear stress. As shown in this figure, so while removing a wheel to change a tire, so a driver applied forces 2P equals 100 Newton at the end of 2 of the arms of a leg wrench, as shown in here. So assume each arm of the wrench is A equals 225 millimeter and has a solid circular cross section of the diameter D. So that is to say here, your diameter in the arms and in the shaft are all D equals 12 millimeter. So determine the maximum shear stress in the arm that is turning the nut. Look here, of course, our equation will be tau max equals torque by C over J. Here the C is the maximum distance from the edge, or from the point of concern, whether it is the edge, to the centroid of the cross section. Right, so here the T can be calculated by P by arm, by 225, and we have 2P, right? So plus another one. So that is our P equals 100 Newton, so this will be 45,000 Newton millimeter. And the J, this is a solid circular nut, so the J equals pi over 32 by D to the fourth. This is pi by 12 to the fourth over 32. You will get 2035. The unit is millimeter to the fourth. And then the C here, obviously, is half D, right? It's half of the diameter. This is the radius of the cross section, and that is 6 millimeter. Then the tau max can be calculated directly by 45,000 by 6 over 235. You get 122.7 MPa. Okay, here you just need to directly use this equation here, but you need to identify the correct numbers, values of different parameters like a T, C, and J. Our example 2, we can look at the structure here. The structure looks similar, but actually is a little bit different. Then the pipe AB shown in the figure has an inner diameter D equals 80 millimeter and an outer diameter 100. If the end is tightened against the support at A, the end is tightened here, it cannot move at all, cannot be rotated. And using a torque wrench at B, determine the shear stress developed in the material at the inner and outer walls. But you're requested to determine the stress here and here, right, along the central portion of the pipe in this section. But no matter how, you will need to calculate the shear stress. Actually, it's the maximum shear stress at this edge and this edge. Right, so our equation will be tau max equals TC over J. So our T in this case can be calculated as P by A plus P by B. And in this case, your A and B are different. Right? A is 300 and B is 200. Right, so here the force is 80 Newton. So this equals 80 by 300 plus 80 by 200. So here you will get 40,000 Newton millimeter. Okay, then the J equals pi over 32. Since this is a tubular cross section, tubular tube, right? So you would just get this equation: the external diameter to the force minus inner diameter to the force. This is pi over 32, 100 to the force minus 80 to the force. Then you will get 5.796 by 10 to the 6 millimeter to the force. So now let's look at the maximum shear stress at the outer wall, at the inner wall and outer wall. So let's look at the outer wall first. For the outer wall, C equals half D, right? Half the outer diameter. So this will be 50 millimeter. So your tau max will be 40,000 by 50 over 5.796 million. So then you will get 0.345 MPa. And at the inner wall, the C equals inner diameter over 2. So that is 40. Then the tau max. Let's see, here's the outer wall and here is the inner wall. So this one equals 40,000 by 40 over the same J. So 5.796 by 10 to the 6. So this will be 0.276 MPa. So that's it. And for the example 3, this example is a simple design problem. So a solid circular shaft is subjected to a torque of 9,200 pounds-inch, and the maximum allowable torsional shear stress generated is 13,000 psi. Then find the required diameter of this shaft. Sure, this example, this problem can be summarized as this. Okay, our tau max equals tau torque by C over J, and this should be not higher than the allowable shear stress, and that is 13,000 psi. Okay, so here in this equation, and our C equals D over 2, and J equals pi over 32 by D to the fourth. So tau max equals T by D over 2 over pi over 32 by D to the fourth. So this one can be simplified as 16T over pi D cubed. Okay, from this equation, you can rearrange this equation. Then you will get D cubed equals 16T over tau max by pi. So this is 16 by the T we already know here. Right? This is 16 by 9,200 over pi multiplied by 13,000 psi. So here you will get 3.6 cubic inch. Right, then from here you can calculate that D equals 1.42 inch. So as a design problem, so since you know the allowable torque is 9,200, so if you design this thing, you should make sure that the D is larger, not smaller than 1.32 inch.